right, let's talk about a mystery. Why not? So, here is a specimen of a Cyathonema, digermulens, or digermulens, maybe? I don't know. And it just looks like a little black smudge in a rock. This is a little polished section of a rock. But these are from Norway, and these are very, very old. So early Ediacarans, so a little over 500 million years old, somewhere around 600 million years probably. So what are these guys? What are they? That's the question. Are you dealing with something like a smudge or something like a body fossil? And the way you tell is going to be by looking at the details, of course, as with anything in fossils. So let's look at the details. Let's get into it. So if you were to etch those out of the rock, so here's one in the rock, here's one where they've dissolved away the rock with acid and left the fossil, which was preserved differently. So it's got a different preservation, so you can dissolve the rock and leave the fossil intact. It's really nice when that happens. That does not always happen. Quite frequently, that does not happen. Anyway, look a little closer, and now it doesn't look like a smudge at all. Look at that. This is a network of tubes. The tubes have little openings. The openings are clustered together. Inside the openings, sometimes there are little, like, look at that, little connectors between them. Yeah, what's going on here? What are these little things? And so the detail that you see here, these sort of twisting tubes, that doesn't look like any mineral that I've ever seen. They tend to be crystals. They tend to grow by sort of regular stacking, smooth sides, something like that. This looks organic. It looks as though we are dealing with some kind of fossil. And it may be something related to this up here. That's a blob of choanoflagellates, like little primitive single-celled sponges. All right. Let's look at some more of these things. This is the same group, but what are some of the other features? If you look inside, some of the open ends, there's like a little collar around there. See that little collar? And here's another little collar right here, and there's maybe a little collar right there. It's kind of blocking it. Here's a little collar. There you can see a nice little complete one. Here's a nice little complete collar up here. And you can see bits of some other ones. So it looks like all of the open ends are pointing together. There's sometimes a little collar there, so there would have been some projection of the animal's body coming out. What we've got here is probably the case around the outside, basically an exoskeleton for something. Yeah. And yeah, it's kind of a question like, what is this something? With a lot of early, probably animals, because this is before we really have multicellular plants. So with a lot of early animal-like fossils, they'll get a name. They'll get a genus and a species name, but they sometimes won't get attached to any family or order or, phylum. Just because it's not certain where they sit. So the Latin word for that is incertae sedis, Incertaesedis, and just means uncertain where it sits. Yeah, where should I put this thing? And if you don't know and you put it in the wrong group, then you're creating an unstable taxonomy that's going to eventually collapse. And so the responsible thing, the conservative thing to do is to just say, here's the genus. Eventually we'll find more of these things, maybe, and then we can think about putting them together and making a larger group. So even though the names are available all the way up to family, and we could attach names that are even higher, I'm just not ready to do that. And that's fine. That is okay. Yeah. Because if you're publishing this, you get to make that call. And in this case, that would actually probably be the right call. All right, so let's look at the fossil. And so you can see here it's got traces. This is from energy dispersive X-ray microanalysis. So where you shoot some energy at these things, and you'll read the amount of energy that comes back. There's some fancy physics that happens, and it's different for each element. So it's element specific. And so here you can see that if you zoom in on this little part in the square, there's a ton of carbon and a bit of oxygen. That already sounds pretty organic to me. Yeah. And then you've got some aluminosilicate. That's probably going to be the matrix that's around them, or maybe it's like fossilized onto them. You might have some nitrogens cross-linking to some of these compounds. Bit of potassium, probably also from the rock, and a bit of titanium. So there's some titanium in this rock, and that's cool. If you look though, so here's the picture. So everywhere that's carbon is going to light up red in here, and so it's pretty much the center of the fossil, and all the parts of the fossil light up. But look at this part that lights up for titanium. It's this little blob on the side. And so you can say, oh, well, this part is probably the fossil, and that's a little piece of rock that's stuck to the fossil, because it's got all the titanium in it, and probably the aluminum and the silicon as well. Same thing over here. The center of this beast is where all the carbon is in the body of the fossil. So yeah, it's like if you died and they looked at your bones, they would find a lot of carbon in there, a lot of phosphate in there if they're looking for that. You can see the titanium is all clumped together, and like this little nugget right on the side, that's a little bit of the matrix around it. So is this. Those are not fossil, and this main part is fossil. And this also, this little, see that side island? Yeah, not fossil. That's part of the matrix. So there you go. So you can actually tell. The fossil has a different composition from the rock around it. And that is a key for any sort of body fossil. They'll be a little different in composition, elemental composition from the rock around them. If you have something that's just like an impression, like a mold, then those will not be different because you have lost all of the actual organic material of the fossil there. So you can still name it, but yeah, there is less information preserved in fossils like that. So here's an example of something that you can actually do with fossils around where we are. These are rugose corals. They're all oriented with the cardinal septum at the bottom, the counter septum at the top. And these are a couple different kinds, 3 different genera of rugose corals. This one has a really short cardinal. This one has a really long cardinal. Look how big that one is. Sticks right up. And this one has a long cardinal and doesn't kind of connect in the same way as some of those other ones. It doesn't grow in the same way. And they start at different points as well. But what you can see here, this is the light picture, and those are pretty hard to see, but these things light up under ultraviolet light, and what you're seeing is a bit of uranium that is trapped inside the calcite crystals. And uranium glows a beautiful fluorescent green, very high energy. They used to use this for decorative glass. There's depression glass from the 1920s, and if you shine a UV light on it, it is just gorgeous. You can find these in secondhand shops, flea markets, that sort of thing. And they're pretty safe. It's usually depleted uranium. Yeah. So let's carry on. All right. So what are these things? Well, here is the reconstruction, and when you publish it, you get to publish the reconstruction as well, and hopefully you get it right. Yeah. So we've got a little collar around the inner opening. We've got the outer opening. Some of these things appear to have a domed end, so maybe they're facing the opposite direction, or maybe sometimes it has a dome, sometimes it doesn't. There may be connectors between some of these things. A little tubular thread, like a little hollow tube. Like, yep, that was most of the fossil. And so is this arrangement similar to what we would see in a living organism? I would say yes, because you've got ends, you've got differences, you've got a bunch of individuals pointed in the same direction, which is probably where the food is or where the babies needed to go. Yeah, you'll get this with, think like corals, where you have all the polyps that are all facing more or less outward from the coral head. What clues do attachment points and orientation of openings give us? Yeah, so if they're all growing together, it is possible. Like, why would a bunch of genetically distinct individuals end up in the same place? These may actually be offspring of each other. This may be colonial, or it may be an organism that reproduces by budding, for example. And the fact that all the orientations, or most of the orientations, are in the same direction tells us that there is probably some important reason connected to staying alive, why you would see this. You would not expect to see this with just a mineral. They would have orientations like this. Minerals generally more like crystals. Let's see. If you had to speculate on the affinities, well, the authors speculate they think it is something like a primitive coenoflagellate. So, like a primitive sponge with a little collar, and the collar would be either right here or maybe right up around here, and maybe a flagellum poking out through there. So, imagine a little wiggly flagellum coming from each of these holes. And yeah, you could have yourself a very early colonial coenoflagellate, which would be on its way to becoming a sponge, maybe. But these things are going to be in what we would call a crown group. So they are so far back that trying to relate them to a modern sponge, these could be the ancestors of modern sponges and dinosaurs and arthropods at this stage. We're that far back. We're like very early animal, and this may turn into all of those. So picking one of those categories and stuffing it into one sometimes not a good idea because it's not reflecting reality. Yeah. And so, a smart thing to do with taxa like this is to say, you know what? It's in a crown group. It's part of the group of things from which these other little branches eventually emerged. There you go, crown group. All right, and that's the end of this one. So that was just a nice little example for what you do when you're encountering something completely new, very old, and rather difficult to interpret. And you look closely, you examine the elemental, like microfossil and molecular fossil character of this thing, and all of that is information. And you try to relate it to modern living things as best you can, but you keep in mind that in the crown group, things may have been a little different. You have a lot of possibilities in the crown group, and those branches get pruned so that you only have certain possibilities that end up very far from each other going forward. But those were both part of the original crown group. Yeah. All right. Thanks very much.